this is one of the samples from our rock cycle. And if I was looking at this for the first time, I would think, right, well, what observations can I make? What can I see from this? Anything at all? And if I was explaining this to someone who hadn't seen a rock before, perhaps, I would say, right, just say anything at all about this rock. And to me, if I looked at that for the first time, straight away I'd go, right, that's grey, and that's fine. So colour is really, really important. And different colours tell us different things about the origin of rocks. So noting that it's grey is really important. And then if I look at that, I go, well, I can see some different, oh, I'm having a visit from the cat here. So I can see different bits and pieces in there, all are different shapes and sizes. So I'm just going to move the cat, sorry, Esme. And to me, they're all different sizes. So I can see larger pieces in there, and I can see smaller pieces. And those pieces we call clasts or grains. And I can see some small ones around the top, and I can see some small ones around the bottom, but I can see some bigger ones across the middle. Esme's desperate to join in with us. Come on, you. So we've got different sizes of clast, and if you see this little box at the bottom, this little cube, that cube is what we call a scale, and that scale is a centimetre in size. It's a centimetre across, so that tells us something about the size of those grains or those clasts in that rock. So we've got some grains in there that are getting on for a centimetre across. So then we could look at the shape of those grains or clasts in there. Now those grains, do they look rounded or do they look perhaps angular? Can you see some straight edges on there? And if I look at that, I can see some that have definitely got rounded edges. So where my cursor is in the middle, but also there are some that have very straight edges. So if they've got straight edges, we would call that more angular. But we have some very rounded ones as well. And I would look to see whether there was just one clast type or whether there were different types of clasts. And I think if I look at that, I would see just one clast type. They all look to be grey to me. There's a little bit of variation in that shade of grey, but I think that's just one clast type. We can comment on whether they're touching each other, whether they're in contact or whether they are separate. And I think if I look a little bit closer up, to me, they look like they're further apart. So that would be an important feature to make a note of as well. Are they pointing in any particular direction or are they random? I think that that's probably random. There seems to be no particular pattern to any of that. Perhaps the finer ones, the smaller ones are at the top and the bottom, and the bigger ones are in the middle, but they don't all seem to be pointing in a particular direction. So we've just done that in what, 2 or 3 minutes. We've been able to describe that rock on the basis of what we can see, and that's what geology is about, describing what we can see. So there are terms that we'll come to learn, but actually we can do an awful lot without that terminology. So we can use those observations to help us to try to interpret this rock, because any rock has got to have formed in a particular environment somewhere. If something has got, I'd say, primarily angular edges, so straight edges, does that suggest it's been travelling around and it's been moved around in perhaps water for a long time? Or perhaps has it just been moved around for a small amount of time? And I think if it's got straight edges like that, it's actually been broken up and it hasn't been travelling very far. Because if it had been travelling for a long time, those straight edges would have been rounded down lots and they would have been smoothed down. So this is a rock. However it formed, we had a process that meant that those grains of rock didn't travel very far at all. They haven't had a chance to be worn down. Now I'm going to tell you what this is because I wouldn't expect you to know at the moment, but this is actually a rock from Sicily. It's probably about 100 million years old. And these clasts in here are made up of a rock called limestone. Now, some of you might be familiar with limestone. Limestone is made of calcium carbonate, and sometimes it has fossils in there, and it forms in shallow seas. But those fragments started off life as one big rock, and then they were broken up into fragments, and they fell down fissures or cracks in the ground. And you can go and find like an area in Sicily where we have these great big fissures where these rocks have broken up, falling down into these cracks. That explains why they are so straight-edged rather than rounded, because they literally haven't travelled very far at all. So that's the sort of thing we might be doing in the rock cycle. What I didn't say was you might be familiar with different rock types. This is what we would call a sedimentary rock. So a limestone is a sedimentary rock, as opposed to an igneous rock, which is from a volcano or volcanic in origin, or a metamorphic rock, where those rocks have been affected by temperature and pressure and changed.